What's up, guys? Today we'll be going over lesson 8.6. And 8.6 is all about all the quadrilaterals together, so we'll just call them all special quadrilaterals. Alright, before I start example 1, I'm only going to do, I think, 4 or 5 examples right now, this is a real quick video. This is a real nice, easy lesson, because it goes over all the quadrilaterals, and you need all the notes from 8.1 all the way to 8.5 to do this lesson. It's like a nice review before we review for the test. And just keep in mind, I'm only doing 4 or 5 questions, but this lesson is over all the lessons put together, so when you get your work, it's very comprehensive. So let's get started. Example 1. What shape is that? I know what you're gonna say. You're gonna say this. Square. And I'm gonna say negative, because it can also be this, because it's 4 sides congruent. And then you're gonna say negative. We don't know what shape this is. It looks like a square, but the problem is it has all 4 sides congruent, which is a square. It's also a rhombus, but it can't be a square because it doesn't have 90 degrees. It has to have 90 degrees for it to be a square. And I know it looks like it, I know, but take it easy. It needs to have a little symbol. If it doesn't have it, then you can't assume it's 90. It doesn't say they're perpendicular or anything, so it can't be a square. A rhombus has 4 congruent sides. Awesome. But a rhombus also has diagonals that are perpendicular. This shape doesn't have diagonals, so it's not either one of these. There's no answer, no solution. Alright, so example 2. Is enough information given in the diagram to show that the quadrilateral FGHJ is an isosceles trapezoid? Isosceles trapezoid. Is this a trapezoid? Yes, it is. Is it isosceles? Well, isosceles trapezoid means that 2 base angles have to be exactly the same. 102, 102. It's the top, but yes, it's still the base if you flip it over. So 102 degrees means that FJ is congruent to GH. So yes, is there enough information? Yes, there is. Alright, example 3. Example 3 says, is there enough information here to prove that this shape is a rectangle? Is this shape a rectangle? So to go to your notes, find rectangle, and see what it says. Rectangle says that these 2 sides are parallel, so we're good there. And it says you have to have 90 degrees. We don't have that, but okay. It also says that the diagonals have to be congruent. That one equals that one, and that one equals that one. Do we have that? Yes, we do. Since we have the diagonals all be congruent and the sides that are parallel, we can say, yes, this is a rectangle. There is enough information. And it's going to ask why. It's one of the questions from your work. Explain how this is a rectangle. Well, 1, opposite sides are parallel, and 2, and most importantly, the diagonals are congruent. That proves that that shape is a rectangle. And the last example, example 4, says I know there's no directions, but I'm telling you. What additional information do you need to prove that this is an isosceles trapezoid? In other words, you want to make this shape an isosceles trapezoid. Well, do we have a trapezoid? Yes, we do. The top and bottom are parallel, they don't touch each other. And isosceles. Isosceles means two sides are the same and two angles are the same. Two sides are congruent and two angles are congruent. So let's make some sides congruent. I'm going to say FJ is congruent to GH. So 1. FJ is congruent to GH. 2. Remember, this angle belongs to, this side belongs to this angle over here. So angle G, that's too low of a name, so let's call it FGH. FGH is congruent to this side here, congruent to this angle over here. We'll call it JFG. Angle JFG. Now right here I gave the fancy name. You don't need it. You could have just called this angle G congruent to angle F. This one, that's middle school right here, ladies and gentlemen. We don't do that no more. This is the big leagues. We do it right here. FYI. They both mean the same thing. They're both the same answer. But the top one right here, that's what I'm talking about. This is the more proper answer. Oh yeah. So that's it, guys. I told you it was a short lesson. We didn't even use any numbers. Sweet, simple, easy math, shapes. And it was an easy lesson for me because, well, I have memorized all the rules for a kite and trapezoid and rhombus and parallelogram and rectangle and square, and all of them. I have them all memorized because I'm a math nerd, so that's why I have them memorized. And well, I'm a teacher, so I have to. So make sure you have your notes, and that's pretty much it, guys. Oh, and before I leave, one last thing. For some bonus tomorrow, I'll drop your, I'll drop another lowest homework grade if you get it right. So 3 sides is a triangle, 5 sides is a pentagon, 6 sides is a hexagon, 7 is a heptagon. Know that. What happens if we keep on going? 8, 9, 10, 11, 12, 15, 18, 19, 34. I know if that's 34 gone. If you keep on, does it ever stop? That's one question. Does it ever stop? And the big question, can you have an infinity gone? If so, what does it look like? Just put that on top of your work tomorrow, the answer you think it is, and I'll give you credit if you get it right. If not, plus you got it wrong. Laters.